So we're talking about chapter 3, and that's going to be linear functions and quadratic functions. So 3.1 is linear functions. 3.3 is quadratic functions. After this, we're moving to chapter 4, polynomial functions. So x cubed and higher, rational functions, fractions, radical functions, and then chapter 4 is inverse functions, exponential functions, log functions. That's chapter 5, and then chapter 6 is trig, right? So we're just trying to see every type of function you're going to see in calculus, right? So, but these two are pretty simple. In fact, we've done them all already. When we did the arithmetic series and the sequences, we already talked about lines. You've talked about lines probably for the last 4 years of your mathematical life, and quadratics probably the last 3 or 2 or something. So, and we already talked about quadratics as much as we could. And so again, the most difficult part there is completing the square, and we'll do a couple more of those today. So let's start with our linear functions. And so we're talking about what, y equals mx plus b, or better yet, f of x equals mx plus b, right? And so, well, can you find the slope there? Can you find the y-intercept? It's really, really simple stuff, right? Can you find the average rate of change, which is difference quotient? Can you graph it? Maybe that's the most difficult piece. But we also want to be thinking of what y minus y1 equals m times quantity x minus x1, right? And we have a new one, a sub n equals a sub 1 plus d times n minus 1. There's our arithmetic nth term, which, it's the same as all of these. So there's our theory. Let's see if we can do some problems. Let me open up this homework. So this is homework 13, linear functions. So I'm just trying to provide some insights. I think it's all review, okay? But you're going to let me know. If I'm assuming too much, please let me know. So here it is. H of x is 5x plus 4. And let's just think about everything they could possibly ask us, right? So this is homework 13, problem 1. And then y equals 5x plus 4. So what's the slope here?
5.
Nice. What's the b value? Is 4, right? mx plus b. And they also call that the intercept. I'd rather call the y-intercept 0, 4. But I can't stop the computer program from saying that the intercept is 4. I like to say the b value is 4. When I'm talking about an intercept, I'm talking about a point on an xy grid. So I want an x value and a y value. The other thing I guess I would want to think about here is m is delta y over delta x. So that's 5, which is 5 over 1. So delta x is 1, and delta y is 5. So as I'm moving my x values by 1, my y values should move by 5, right? So I can generate a table pretty quickly. At 0, I get 4. There's my intercept. And it's saying to me I should move my x's by 1, so 1, 2, 3, and then my y's by 5, so 9, 14, 19. Right? Is that comfortable? And of course, you could just plug in the x values and get the y values. So you always have these little safety nets of, if you're not thinking about it abstractly, you can think about it directly. Clearly, I can put a 1 in there. So 5 times 1, what's the function again? 5 times 1 plus 4 is 9. Okay, got it. 5 times 2 is 10 plus 4 is 14. Got it. So, but the more you can think about that table and how it's generated like an arithmetic sequence, right? That there you're having that more sophisticated thought, which is what we want you to do. Now, when I used to teach 8th graders how to graph this, I'd say this is where you begin, and this is how you move. Mx plus b, right? So I'm beginning at 0, 4, and I'm going up 5, 1, 2, 3, 4, 5, and over 1. And there's my line. So I went up 5 and over 1, right? There's my delta y over delta x. But again, can I plug those in? Yes. Can I graph the thing in my calculator? Yes. Can I look at the table in the calculator? Yes. You can do all of those things, right? So, but there's really nothing too complicated about what's going on, but we're trying to think the next level. We're trying to connect those arithmetic sequences. We're trying to connect the walking of delta y and delta x. So let's look at this one, 1/3 x minus 4, right? So this is homework 13, question 3. 1/3 x minus 4. This feel like a review, or anybody confused or worried or?
Like a review.
Feels review-ish.
Yeah.
Right? Nice, good. So homework 13, number 3, let's say number 3, number 4. Number 3, and I've got h of x equals 1/3 x minus 4. So let's think about the slope here. What's our slope? It's 1/3, right? So that's a delta y over delta x. Delta x will always be positive, just because we're always reading left to right in mathematics, at least American mathematics. Is that true in any other? No, it's always left to right. Delta y is 1, right? So I should be able to generate my table here. Clearly, I'm starting at 0, -4. That's my y-intercept. But I want my x's to move by 3's. So 3, 6, 9. And my y should move by 1's. So -3, -2, -1. Right? Is that making sense at all? Now, if I can handle that, it'd be nice to put in 3's to get rid of my fraction, then I don't have to think about the y's. I can just plug in the x's and get the y's. Right? If I plugged in 3, I'd get 1/3 of 3. That's 1. 1 minus 4 is -3. Right? So I don't have to keep it so abstract. I can just figure out what x's work for me, put them in, and find the y's. So if I'm going for my graph, I'm starting at 0, -4. And I'm walking up 1 and over 3. So up 1 over 3. And there's my graph. So I've got 0, -4, and guess what? I've got 3, -3 there. What's nice is to kind of see that I can do this one as an arithmetic series. So a sub n, right? So this is my first term, second term, third term, or whatever. I can call whatever I want as my first term. So my a sub 1 is 3. What am I adding every time? I'm adding 1 times an n minus 1, right? So I start at a sub 1. What am I adding every time? Oh, I'm sorry. My common difference is 1/3, right? So I get 3 plus 1/3 n minus 1/3. Am I doing this correctly? What am I adding every time? Yeah, 1/3. Why do I feel confused here all of a sudden? No, I don't like what I'm doing there. Let me do that one with my past problem. Yeah, this one's better. What's a sub 1 is 1. And what am I adding every time? 5, right? My common difference is 5. So a sub n is 1 plus 5 times n minus 1. That works out better, doesn't it? I don't know why I'm confused with that, but there's my 5n minus 4, right? And there's my y equals 5x minus 4. Same answer. It should work on the other one too. I'm just confused for a second here. But that whole arithmetic piece, right? What's the first term? What am I adding every time? It should come out exactly the same every time. I'm not going to ask you to do that on the test at any place. So I'll do the arithmetic again here to save face. So I give you a table. I say, is this thing linear? Is this an arithmetic sequence? Same question, right? Is this linear? Is this arithmetic? So I can clearly see my table 1, 2, 3, 4, 0, 2, 4, 6. Right? So let me jump to that one here. So this is number question 5 in homework 13. And I give you a table of what, 0, 2, 4, 6? Yeah, 0, 2, 4, 6. And so the question, is it linear? Well, I mean, it's pretty obvious. When my delta x's are consistent, meaning the same every time, and the delta y's are consistent, the same every time, but they don't have to match each other, right? Then we're talking linear, right? If I'm walking upstairs and everything feels the same, that's linear, right? So here a sub n is in question, but a sub 1 is 1. And what am I adding every time? Right? Can you see what I'm adding every time? I'm adding 2, correct? So a sub n, oh, that's where I made my mistake on the other one. a sub n, what's my first term is 0. And then I'm adding 2 every time. So 0 plus 2 times n minus 1. Right? I should be only talking about not what's the index, but what's the value of a sub 1. It's the y value. What's the value of a sub 2? So what do I get here? I get 0 plus 2n minus 2, and there it is, y equals 2x minus 2. And of course, obviously, the slope is 2, and what's the b value? If I work backward there, the b value is negative 2. So I get that same thing every time. So is it linear? Yes. Right? And I can come up with the nth term. I can come up with the y equals mx plus b. How are we doing there? Are we okay? Am I confusing anyone? So there's a few like that. Is it linear? Yes. The next one linear is no. Look at the x's. Look at how x's are changing by 1, right? Delta x is 1 every time. And look at how the y's are changing. I got a minus 5 to 1. That's adding 6. And then a 1 to 4. That's adding 3. So as soon as I see my delta y's aren't consistent, right, then I know we're not talking about a linear here. And of course, the horizontal function, right? This one is linear. So it's just a horizontal line, right? I think where things could be most confusing is these last few problems where I give you 2 linear functions and then I ask you subdomain problems. So I've got 2 functions here, y equals 5x minus 2 and y equals negative 4x plus 7. So let's take a look at this problem. It's number 8. And whenever I give you functions, I mean, it's a good idea to graph them. So the first function I have is 5x minus 2. And the second function is negative 4x plus 7. So I've got a black line and a purple line, and I want to really find out where that kind of separation is. Where is one above the other or vice versa? So I want to find out where these 2 lines cross. So I'm setting up the 2 lines equal to each other. 5x minus 2 equals negative 4x plus 7. And what do I get? 9x equals 9, so I get x is 1. So I know they're meeting when x is 1, and I can find their height by plugging in that x value to either function. And what do I get? A 3? So 1 comma 3. The graph's a little bit off, but so this kind of separator here is going to divide the questions that they're going to ask me, and I'm going to always be trying to write them in subdomains. So like they'll ask, and let me call the purple line y1 and the black line y2. So when does y1 equal y2, and what's that going to be when x equals 1? I'm always talking about x values. If I'm comparing y values, I want my answer as x values, right? So for example, when is y2 less than y1? And for me, that's me saying when is the purple line above the black line, or when is the black line below the purple line? And so you can see that that's going to be anywhere to the right, and we're talking about from 1 to infinity. So we're trying to answer with subdomains of the x's. Isaiah, no problem. Your dad's more important in math class. everybody's here today. I love it. I love when I have an easy attendance day. And Isaiah, I recorded from the beginning, so.
All right, thank you.
Yes. So that's pretty much it for the linears. What do you think? I mean, it's really 8th grade or 9th grade over again. Just with a little bit of, just connecting the arithmetic sequences. Maybe is the little twist on it. But again, there's no direct question like that on the test. Nice. Let's go to quadratics. This is the fun stuff. So 3.3 quadratic functions. So we want to talk some theory and then just go do some problems. So what am I talking about? F of x equals ax squared plus bx plus c, right? And so we'll talk at the end of class. What does a do? What does a do to the function? If I change a, what happens to the function? If I change c, what happens to the function? Those are easy. The tough one is if I change the value of b, what happens to the function? But what about our domains? What about the domain of quadratic functions? Very good, class. All reals. Thank you. What about the y-intercept? Very good, class. 0c, right? I'm just when I get a y-intercept, I plug in x is 0. What about x-intercepts?
You plug 0 into y value.
Good, and I get minus b plus or minus the square root of b squared minus 4ac all over 2a for my x value. If it's real, right? If it's not real, if I get the square roots of negatives, I'm going to ignore it. We're going to say there's no intercepts in that case. If a is greater than 0, then we're going to we'll say the graph opens up, right? If a is less than 0, our graph will open down. And then in each case, what's the domain? What's the domain? I'm sorry, what's the range if my graph opens up? Right? What's the range if the graph opens up? What's going to be from the vertex up? So I'll call it y sub v to infinity. And if it opens down, it's going to be from negative infinity to y sub v. So remember, y sub v, that's what I use to say the y coordinate of the vertex. What else? Factored vertex form. It's going to be a times x minus x sub v quantity squared plus y sub v. Right? This is my vertex form that we learned at least how to do by completing the square last week, if not before, right? And so x sub v comma y sub v is the vertex, and x equals x sub v is the axis of symmetry.
Professor?
Yes.
I'm sorry, I'm a little confused about like what the V is like.
Yeah. So I use that subscript v as telling me that, so this particular point is an xy, but I'm saying it's the it's the vertex, so I'm calling it an x sub v. It's the x coordinate of the vertex and the y coordinate of the vertex. It's just my notation. Some books will use hk. So I'm just saying if I can find that point, I know that's the x value of the vertex, the y value of the vertex.
Okay, thank you.
Yes. I think that's all the theory. So let's jump right into some problems and see how we do. There's a couple things there that might be confusing, but I think if for test 2, you're going to have all of this on your formula sheet for sure. Maybe for test 1. But let's see what happens. Let's do some problems here. So I'm looking at homework 14, quadratic functions. And again, I think the most difficult thing in this chapter is completing the square. So I'm trying to focus there because you'll complete the square in Calc 1 and Calc 2. So the easiest way to match this graph is to complete the square. So let's do it, right? So I've got x squared plus 16x plus 64. No, I did. I get x plus half of k quantity squared. So I can see that I've got x plus 8 quantity squared. I have a vertex of negative 8, 0. And remember, x's behave inversely, y's are direct. X's are inverse, y's are direct. So take the opposite of that x for my x sub v, and take the y as my y sub v. Take that leftover piece on the outside. And so now I can see the answer has got to be this one, right? It's got to connect at negative 8, 0. Here's a good one, number 4. I want to graph this function, right, by completing the square. So just like last time. In fact, let's see if we can answer some other things for this one. Let's find a domain. Let's find a range. Let's find intercepts, right? See how much we can do on this one without even getting a prompt from the computer. So I've got homework 13, number 4, and I've got f of x equals 3x squared minus 24x plus 46. And I want to graph it. I want to get the domain. I want to get the intercepts, maybe the axis of symmetry, everything I can think of, right? So, but the way we're going to start is complete the square. So we're going to factor out a 3 from the first 2 terms. Is this okay with everybody? Everyone okay here? I don't have my chat open.
Yes.
Thank you.
Yep.
Thank you. So I want to, I would call this piece B. I'm calling this number K, right? So ax squared plus bx plus c. And I like to, once I factor out this leading coefficient, I'm now using a different letter. So I'm saying k is -8. Half of k is -4. And if I square that, if I take half of k and square it, I get 16. So I'm adding 16 on the inside, but I have to notice that that's actually a 48. I've actually added a 48 to my function, so I have to get rid of the 48. Is everybody with me there? Nice. Elise, Manish, Ryan, you're all there. Nice. Cool. Now, I could go back to 8th grade and factor this. What two numbers multiply to 16 and add to -8? Or I could just realize that I get x plus half of k quantity squared every time. So f of x is now 3 times x minus 4 quantity squared. Help me, plus 16? Yeah. So I get my vertex is coming from 4, 16. And I know it opens up, so I can definitely say something about the x-intercepts. They don't exist. There are no x-intercepts. I've got a vertex. I've got an axis of symmetry. Right? It's symmetrical about this line, which is x equals x sub v every time. Or in this case, x equals 4. I've got a domain of everything for all polynomials. And I have a range of vertex and up. So 16 to infinity. Remember, range is y values. So what's my smallest y value up to my largest y value? What else do I have? I have a y-intercept of 0.64. That's about it. You can't do much else. Right? They can't ask me anything else about quadratics. How are we doing? I feel like I'm going fast here, and I'm okay with going a little fast because I know I need the time when I teach you chapter 4, 5, 6, and 7. I need more time then. So if I can do this stuff, which I think is review or should be review, if I can do that quicker, I'm okay with that. So, but you got to let me know, right? You got to communicate with me. You got to do problems and ask for help. Let's do one more. All right, here we go. Quadratic function minus 2x squared plus 2x minus 5. And let's see if we can do everything we can with it. So what would I want? I'd want a vertex form. I'd want a graph. I'd want the vertex, axis of symmetry, domain, range, intercepts. That's about it. Right? Everything I can think of that I would need for a quadratic. So this is homework. It's homework. Is it homework 4? I said 14. I think it's 14. Doesn't matter. Number 7. You know which one I'm doing. It's 3.3, right? So I've got f of x equals negative 2x squared plus 2x minus 5. And let's see if we can come up with everything we need for this and then see what they want. So domain we know, right? All reals. What else do we know? Intercept. Y-intercept is 0. Is when x is 0, right? Intercept. So 0, negative 5. We know it opens down, right?
Yeah.
So we're doing something like that or something like this, right? We don't know if it goes through the x-axis yet, but we'll figure it out. So let's complete the square, right? So f of x is what? Let's factor out a negative 2. And I get an x squared minus x minus 5. I'm factoring out that negative 2 from the first two terms, from the x squared term and the x term. Everybody there with me? Let me give you a second. Is everybody there? Elise is there. Elmer's there. Ryan's there. Wilder's there. Sarah's there. Everybody's there. Beautiful. So k is negative 1. Half of k is negative 1/2. Half of k quantity squared is positive 1/4. I'm going to add a 1/4 on the inside, but notice that is times a negative 2. So I have to make sure I add a 1/2 on the outside. Make sure you're with me there before I move on.
Can you explain that again?
Yes.
The 1/4 and 1/2, please.
Good. So the 1/4, we know where we got it. We're going to put that inside the parens. But then if I distribute the negative 2, notice I have a negative 2 times a 1/4. That's a negative 1/2. That's what I have to cancel. That negative 1/2 is what I have to cancel. So I cancel it with adding a 1/2 at the end.
Okay.
Yeah, and it's that simple to say, okay, I did this. What do I really have, right? And so you're going, okay, well, there's my negative 2x squared, got it. There's my positive 2x, got it. There's my negative 5, got it. So then I have to make sure these last two pieces, right, this times this and this add up to nothing. And so it's just tricky to get used to it, that's all. So now what do I have? I have my function is negative 2 times x plus half of k quantity squared every time. Don't think about it. Every time it's going to factor into that. And then I have minus 9/2. Negative 5 plus 1/2 is 9/2. Oh, this is telling me something. It's telling me that my vertex is at 1/2 9 minus 9/2, and it opens down. So there are no x-intercepts. There are no real x-intercepts on this particular one. X equals 1/2 is the axis of symmetry. (1/2) negative 9/2 is the vertex. There are no real x-intercepts. My range at the lowest is negative infinity all the way up to the highest of negative 9/2. And it's everything we could possibly do. And you're like, well, how am I going to remember what I'm supposed to do? Well, MathXL is going to prompt you. What's the range? What's the vertex? What's the axis of symmetry? What are the intercepts? It'll prompt you. And then, you know, you'll catch on to what you need to be thinking about. Nice. I think we only have one little bit of theory to talk about today, and we're done. So, which is kind of nice. So I made a sketch, and this is not something I'm expecting you to be able to do. You certainly could try and come up with it on Desmos, which would be cool as hell if you could. I've created it on Sketchpad, so this is a program that's not free. So what I've created here is a little sketch of ax squared plus bx plus c. And so the question is, what happens to my graph as I move point A, as I move point B, as I move my point C, right? So let's start with moving point A. So when A gets very large, it's stretching the graph out this way, really, really tall. And as A gets closer to 0, it gets really, really wide, right? As A gets closer to 0, it gets really wide. And of course, when A is 0, it's a straight line. And when A is negative, it opens down. And the same aspect happens, right? So as A is negative, it opens down, stretching it this way, right? When it's between 0, -1 and 1, it's getting really kind of stretched out wide. But positive A values will give me a quadratic that opens up. Negative A values give me a quadratic that opens down. But you all knew that. Am I right? Is that fair to say?
Yeah.
Yeah. What happens when I move C? When I move C, remember it's ax squared plus bx plus c. When I move C, I'm adding a y value, right? I'm adding something to the outside. So if I add a negative, it moves the whole graph down, right? If I add a positive, it moves the whole graph up. So here's the trickiest question. What happens when I move B? What happens when I move B? When I change the value of B, what's happening to the graph?
It's moving to the right and going down.
Okay.
I mean the left and going down.
Okay, so when B is getting bigger, it's doing that. Right? What happens when B gets smaller? When B gets negative? I like that you. So is it changing the shape of the graph, or is it just moving the graph? How about that? Is it changing the shape of the graph, or is it just moving the graph?
The shape is changing.
So you think it's getting kind of wider or skinnier?
Yeah.
Try and focus, Sarah. Focus on the vertex. Do you see the vertex kind of, that very tip? Is that changing size, or is that?
Oh, okay.
So no, right? No.
No.
So what I'm going to do is I'm going to put my vertex on, and I'm going to trace it. Okay. So I put my vertex on. I'm going to trace it. Now I'm going to move that. I'm going to move B again. What do you see? Anybody?
It kind of looks like it's making the reflection of it.
Exactly. It's tracing itself out upside down with an axis of symmetry at C, right, on the y-axis. So wherever C is, it's using that as the center, and it's retracing its own graph but upside down. Quite strange, quite beautiful. But they never showed you that before. They only showed you what happened when you changed to A. Because it's kind of hard to explain what's going on here. That's probably why. It's pretty complicated. But just something kind of pretty to look at, but that's also my opinion. So you've got lots to do. Lock down browser. Get the study guide done, right? Get me some questions to make sure you're ready for the test. Get your formula sheet written up. I think that's about it, right? So I'll see you Wednesday. I'll stick around if you have questions or concerns, okay?